All right, so a discrete, sorry, probability distribution has to have two things. The probabilities have to add up to exactly one, and well, I guess none of the probabilities can be negative, so that's important also. Um, and so if we look at, so technically all the probabilities have to be between 0 and 1, but if they add up to 1 and they can't be negative, then it wouldn't be able to be above 1 anyway. So when we see a distribution, these are the possible values of x. You can think of a kind of a crazy dice that has a 0, a 3, a 4, a 5, and a 6, no 1 or 2. These are like the possible outcomes. So the thing to note about this problem is that these values don't matter at all. If we're trying to give a legitimate probability distribution, we only care that these numbers over here add up to 1 and that none of them are negative. These numbers over here, by the way, could be negative. This could be negative 20. This could be pi. This could be whatever. They don't really matter in terms of forming a legitimate probability distribution. So let's go ahead and see what we have so far. We have 0.24 plus 0.20 plus 0.16, and that gives us 0.6. Well, 1 is what they need to add up to, and currently they add up to 0.6, so we need to get 0.4 more. 1 minus 0.6 is 0.4. There's 0.4. If we can make these two numbers add up to 0.4, then the whole thing will add up to 1. Doesn't matter how we do that. Let's do 0.38 and 0.02. You could have done 0 and 0.4. You could have done 0.2 and 0.2. You could not have done 0.5 and negative 0.1 because we're not allowed to have negatives. But as long as these were two numbers, 0 or higher, that add up to 0.4, then it will be a correct, legitimate distribution.